Okay, this is section 5.5, and we're talking about slope. And it's fitting that it's like getting near winter time when we hit the slopes, because slope is like a hill or a ski slope. It's where you get to go down the hill. So the slope of a line is the same between any 2 points on the line, because a line has a constant rate of change. So the key idea here, slope is the rate of change between any 2 points on a line. It is the measure of the steepness of the line. To find the slope of a line, find the ratio of the change in y, that's the vertical change up and down, to the change in x, the horizontal change, side to side. And to find the change in something, we subtract. So we're going to find the slope by finding how much it goes up and putting that over how much it goes over. Let's see what we mean. In example 1 here, finding the slopes, it says find the slope of each line. The slope is the change in y, we call that the rise, how much it goes up, over the change in x. We call that the run, how much it goes over. So the change in y, it went, remember, these coordinates come to us x, y. Y is the second number in each coordinate. So for A, it goes from 0 up to 4, just looking at the y portion of the coordinates. So the change in y is 4. For the run, it goes from 0, this is the change in x, from 0 to 3, which is a change of 3. So for that first green line, its slope is 4 over 3. Change in y over change in x. When we look at B, we have that green line there, and we look at the first coordinate. We're going from left to right here. The y is -2. For the second coordinate, the y is 1. So to go from -2 to 1, you went 3 up. So 3 is our change in y. That's what goes on top. Going over, we go from a -2 to a 4, which is a change of 6. So it's 3 over 6, which reduces to 1/2. Well, here are 2 to do on your own. Find the slope of each line. And remember, you're finding the how much did it go up. You put that on the top of the fraction. And how much did it go over. That's what you put on the bottom of the fraction. Simplify if possible. Now, in example 2, we are interpreting a slope. The table shows your earnings for babysitting. And so we look at that table, and it says hours and earnings, but it also says x and y. So the x parts of the coordinates are on the top. The y parts of the coordinates are on the bottom. So the points we can graph there are 0, 0, 210, 420, 630, 840, and 1050, which they plotted each of those points, and they drew a line through those points. So we graphed the data, and we drew a line through the points, and then it says choose any 2 points to find the slope of the line. Now, if the line goes through the origin, which here it does because it goes through 0, 0, then use that as one of the points, because it's really easy to subtract 0 from anything else. So we'll take any other point. For instance, they took 420. The change in y is what goes on top. So 20 minus 0. The change in x is what goes on the bottom. 4 minus 0, which is 20 over 4. And we can simplify that to 5. So the slope of the line is 5. It says interpret the slope. If the slope is 5, that means $5 per hour of babysitting, because it's 5 over 1. I would have left it 5 over 1 and not just a whole number 5, because when you can see it as a fraction, 5 over 1, it makes more sense, $5 per 1 hour. You could have also looked at 20 over 4 and said, well, that's $20 per 4 hours. Also correct. If they want, though, we can go to the unit rate and say $5 per 1 hour. Here are a couple to do on your own. And for number 3, it says in example 2. So you'll have to roll back the video or use your textbook if you have it. But roll back the video and look and see what example 2 was.